All right, guys, so we are going to go through some solving equations. Our first one, pretty basic. We have 4x minus 7 equals 13. And we're going to follow the rules, the golden rules of algebra, which are one, whatever you do to one side of the equation, you need to do to the other. And the second major rule is we're trying to get x on one side and all the numbers on the other side. So this is one of the more basic ones that should be a review. We're going to add 7 to both sides, and we're going to get 4x equals 20. We had 7 here, 7 cancels. We had 7 here, 13 and 7 is 20. And then since it's 4 times x, we're going to do the opposite. We're going to divide by 4 on both sides. And if I divide 4 on this side, I just get x. I divide 4 on this side, I get 5. Any of these we can check. 4 times 5 is 20, and 20 minus 7 is 13, so we know we're right. On the second problem here, we have negative 2 times 4x minus 3 equals 8. I distribute the negative 2 because anytime there's a number outside the parentheses, we distribute. We get negative 8x plus 6. You notice I don't multiply the negative 2 to the 8. Whenever we're distributing, we're just going through that one parenthesis. So now we have negative 8x plus 6 equals 8. We subtract 6 on both sides, we get 2. And we divide by negative 8 on both sides, and we get negative 2/8. If you can reduce your answer, you should do so. And therefore, my answer is negative 1/4. And even fractions will work. 4 times negative 1/4 is negative 1. Negative 1 minus 3 is negative 4. Negative 4 times negative 2 is a positive 8. Here we have 4 parentheses x plus 2 plus 3x equals 15. I distribute the 4 just through the parentheses, and I get 4x plus 8 plus 3x equals 15. Now here, we always want to combine like terms before we start moving things on either side of the equal sign. 4x and 3x can be combined to 7x. That's not algebraic. All right, anything on the same side of the equal sign, we don't really add or subtract. We're looking to combine like terms. And then we try and move things across the equal sign. In this case, I want to subtract 8 on both sides, and I get 7x equals 7. And then divide 7 on both sides, and dividing 7 on both sides, we get x equals 1. Here, we have 7x plus 9 equals 3x minus 3. And now when you have x's on either side, you want to get the x's on one side and the numbers on the other side before you start dividing and multiplying. I subtract 3x on both sides because I want to keep my x positive. That's why I'm moving the x's to this side. So 7x minus 3x is 4x. Subtract 9 on both sides, negative 3 minus 9 is negative 12. And when I divide 4 on both sides, I get x equals negative 3. And even plugging that one, 7 times negative 3 is negative 21, plus 9, negative 12. 3 times negative 3 is negative 9. Negative 9 minus 3 is negative 12 as well. So we get the true statement. Therefore, we know we are correct. It's always nice to know that you are correct. Now, the next two, a little bit longer problems, but the same concept. We're going to distribute here, and we're going to distribute on this side. 5x plus 10 equals 4, and we distribute that negative 3. Negative 3 plus 9x. I combine my like terms first on this side. No like terms to combine on this side, so you just write it down again, 5x plus 10. The 4 minus 3 becomes 1 plus 9x. Here, I'm going to subtract the 5x to this side because I always like to keep my x positive. And I subtract 1 on this side, so I end up with 9. We divide 4 on both sides, and 9/4 is our answer. If I want to put 9/4 in, it will work out. 9/4 plus 2 is 9/4 plus 2 is really 17/4 if you're going to do 9 over 4 plus 8 over 4. So you end up with 17/4 times 5. 17/4 times 5 is 5 times 17, which is 85 over 4. Now, if I do that over here, it becomes a little more complicated. We get 1 minus 27 over 4. 1 minus 27 over 4 is actually negative 23 over 4. And negative 3 times negative 23 over 4 is going to be a positive. Negative 23 times a negative 3 is going to be 69 over 4. And 69 over 4 plus 4 over 4, well, 4 over 4 can be written as 16 over 4, and 16 over 4 plus 69 over 4 gets me to 85 over 4. You get the same answer. And even if you're a little confused by that, as long as you do the algebra right, we do need to be comfortable with the fact that we're going to get fractional answers. And if you plug them in, they will work. It's just weird because plugging them back in to check is actually harder than doing the algebra. So it's something you can do. You don't necessarily have to do, but I wanted you to be aware of it. And the last one is when we have fractions in the problem. This original problem is actually 2/3 x plus 5/6 equals 4. Now what I did was I took the smallest number that 3 and 6 both go into and made that what I multiply both sides by, because that will eliminate my fractions. People struggle to multiply a fraction by a number. All you're doing is dividing by the denominator and multiplying by numerator. And if you select a good number, which is in a lot of cases what we'd call the lowest common multiple of the denominators, it will always eliminate the fractions. You can multiply both sides by 7, 8, 4. As long as you do the same thing to the other side, you can multiply by whatever number you want. The trick here is to pick a number that makes life easier for you. So in this case, 6 is going to make it easier for me because it eliminates the fraction. And all we do is we divide by the denominator and multiply by the numerator. 6 divided by 3 is 2, and 2 times 2 is 4. Now think about that. If I just asked you to do 6 divided by 3, and then I asked you to do 2 times 2, you'd have no problem. So there's no reason why you can't multiply a number to a fraction. 6 divided by 3 is 2, 2 times 2 is 4. 6 divided by 6 is 1, 1 times 5 is 5. And what we do to one side, we have to do the other. So you do need to multiply the 4 times 6 and get 24. That's a common mistake people forget to do. So please make sure you do that. And now we're just subtracting 5 on both sides and dividing 4 on both sides. And we get 19/4.